And then next speaker is Arthur Charpentier. And the topic is really exciting. It's working with genealogical data. So please welcome Arthur.
Okay. Thank you. Hi, everyone. So for those who didn't hear the warning at the beginning, so I'm not David Smith, right? So good thing for you, you didn't miss his talk. He's going to be in the afternoon, okay? So you can still hear David, but we got some exchange. So I'm going to give a talk on some recent work we've done with a postdoc that I supervise, Ewen Gallic. So we're working in France on those data. I just mentioned the GitHub repository where Ewen uploaded a markdown. Okay, so if you want to look at the code, everything is on the markdown, so you can just look at it. I will not put any R codes in the slides. I will just tell you stories and what we've done and explain where we got difficult problems and how we've been able to solve them. And just keep telling you some stories we got from those data. But you can look at the codes online. I just also tweeted a link with the PDF of the article, the slides, the codes. So if you get any question, you can ask us. Okay. So it's about demography and massive collaborative data. So I'm going to get back on the kind of data we've been using. Maybe just to tell you a little bit more about my background. So I'm a professor in economics, and I've been working a lot with actuaries. So I got a lot of interest in non-life insurance and life insurance. And in life insurance, we want to predict when people will die. And the question I've been wondering about for years now is how can we take into account family history, right? So if you tell me that your grandparents died very old or very young, what does it tell me about you? How can I improve my knowledge on your life expectancy? Okay, if you tell me that all your grandparents died very old, should I expect something like plus 5 years or plus 10 years of life expectancy? So it's really to get some kind of quantitative intuition of what's going on if we incorporate some family history when we try to make prediction on life expectancy. Okay, so this was what I started to work with maybe 6-7 years ago. So far, we didn't reach this part, right? So we just managed to get the data 1 year ago. So we spent a lot of time on the data, and I'm going to tell you some story about that. Okay, so now you got the link, so I can move forward. So there's nothing new here. Okay, so we're going to talk about historical demography. So I'm not going to tell you about your life expectancy. I'm going to tell you about your grandparents. Okay, so we're going to get back in history, and there were some work by people really working on that topic, demographs, genealogists, historians. So there were a lot of studies tried to get information from very old data, right? We've seen yesterday in Stefano's talk that data is coming from has a very old history, right? But when you think of life expectancy, you can get back to Halley, who was working on getting the age of death of people just by going in graves and taking notes in graveyards and so on. So it's a long story in the history of probability, in the history of statistics. Okay, and there are some nice data. Okay, so I just mentioned some of them. So you got some in Belgium, right? The famous core data set. So where they were interested by people with the name core something. Okay, so you just look at cities, try to get some old records, and keep tracks of those people. Okay, so they got, I wouldn't say massive data, but kind of big data, like 50,000 people. Okay, so it's a nice data set. We got one similar in France, which is a Tran data set. Okay, so it's people with the name Tran. Okay, so people have been tracked. 6 years ago, I've been able to work with a Canadian data set, which is the Balzac one, okay, which is quite a nice one. People did spend a lot of time on that data set, so it's related to an area in Quebec, which is the Lac Saint-Jean, which is a lake at the end of a fjord. And we have a lot of data for people born there, right? So I wanted to work with those data, so I've been able to get a copy of the data set, but actually there were a lot of problems, because when people moved, we didn't get any updates on what happened. So sometimes we got a lot of people born there, but we don't know if they're still alive or actually if they moved somewhere else. And in that case, so we got a missing value for the age of death or date of death, right? So it's very difficult to focus on life expectancy if you got missing data like that. Okay, so I tried to work with this data set, but basically we decided to drop it and move to something else. I did mention the data you can find in Salt Lake City that you might have heard about. So it's a big data set they have in the US. Okay, and now we start to see more interesting things coming from collaborative data. So it's based on the fact that people are sometimes willing to share information they got. And it might come from different sources. It might come from genealogical websites. So there was a very, very nice article published a few months ago in Science by the team of Kaplanis, who was working with 13 million people, okay, coming from a genealogical website. And actually, this is also what we've done. So we've been discussing with some website in France, Geneanet, and we've been able to get their data. So it's based on French data, because at least in France, we got a nice history with the État civil, which started just after the French Revolution. So we got 200 years where we got official data, and actually we can get some kind of representativity. There was also in the talk of Stefano yesterday a discussion about the big data and the 3 Vs. All of you remember that. And he mentioned the 4th V. And the 4th V was about validity. Okay, can we use the data we can find online? And this is basically the story we have in this paper, and that I'm going to tell you about. Can we use data we have on websites from genealogical websites? Okay, so what is genealogical website? It's a place where you and I can go. We create an account and we create our trees. Okay, so usually you start from you, and then you put your parents and your grandparents. So you keep growing trees in that website. Okay, and the idea was to use the fact that a lot of people actually have an account on those websites, and basically you can get a lot of people. So we wanted to work with this kind of data. Okay, there were also some interesting work on kind of different data set. There was a paper with Wikipedia biographies. Okay, some people have been scrapping Wikipedia, trying to get date of birth and date of death of people, but you can see that there is some kind of bias, right? People on Wikipedia are not everyone. Okay, so there is, so we cannot clearly use that kind of data if you want to focus on life expectancy. Okay, so we've been willing to spend some time on that issue. So I see I still have 10 minutes, so I'm just about to start the talk. So I will be a bit fast on all these issues, but I'm going to tell you about the methodology, about the representativity, and then I'm going to mention very quickly, two examples that we've been dealing with, which is mortality, and how we can replicate actually what was found by the Institute of Demography in France, and something that was not done before, which is about migration. So what happened if you take some people born in a village 200 years ago, and how those people spread between generations. So we've been working on that issue. So about the methodology. So we got this data coming from Genealogical. Maybe just a short story about that, because it was mentioned by a friend of mine working in an insurance company, so he was also concerned with this kind of topic, and he was also very interested by genealogy. Okay, so he has a premium account on Genealogical, and he told me, well, if you want, we can do some kind of scrapping. And I mean, you've all done that, right? Do some scrapping, and this is usually the standard idea. So we started to work on that, and it was quite difficult. And then we had this crazy idea, like, why not ask them directly if we can act the data? And we asked it, they say, yeah, sure, go ahead. Ask whatever you want, and we give you the data. So we were very surprised, and actually, when Ewen was presenting this at the Institute of Demography, I think someone was quite upset because he told us, well, I've been spending months on scrapping these websites, and you just tell me that now we have to ask, and they give us the data. So it was, I mean, sometimes if you want data, just ask for them, and people are kind and they can give you. So we get an access to the data set. So in this data set, what we have is information events, what is called events. Okay, so an event can be a birth, can be a marriage, a wedding, or death of someone. And for those events, we got some information. So we got names, we got dates, and very interesting, we get location. Okay, so if someone gets married at some village, we got at least the name of the village. And the good thing with GeneAnet, because they have some nice apps on their website, it was geocoded. Okay, so we got latitude and longitude for all those events. Okay, so what we've done is, so we started with some users. Okay, everything is based on users. I told you about that. If you want to play with this kind of website, you have to register, and then you're going to create your tree. So everything is based on users. So on this website, there was something like 240,000 users with someone born between 1900 and 1910. Okay, so we got a lot of users, and what we ask is basically get me all the trees for all those users. Okay, so we ended with 700 millions of records. Okay, so it's quite a big data set, and then we started to get some trouble because we wanted to use R to play with the data set, and actually it was not sorted the good way. So we had to play a lot with the data, and it was a huge data set. I mean, from my perspective, I'm coming from economics. In economics, when you do macroeconomic data, you got 40 points. Okay, so going from 40 to 700 is, so I'm going to big data from my point of view. Okay. So we got a lot of data for those people, and we spent a lot of time cleaning the data. Okay, so what we've done is we wanted to start 200 years ago in different locations in France and see exactly what happened. Okay, so if you got a small village lost in the mountains, what happens? Do people stay in this village, or do they go down and go to the big cities? Okay, so we got a discussion about, do people really go to cities? Do people really go to Paris? Or actually, do they go there and get back? Okay, so we wanted to see how people are moving within France. Okay, and what we've done is, so we just focus on 4 years, okay, 1884, and during those 4 years, so we got 1.5 million people, okay, which is quite big, and then we look at all their descendants. So we got their kids, their grandkids, and their grandkids, okay, and then we wanted to look at what was going on within those generations. So this is basically the kind of data we have, okay, so one line is related to one user, one person, and then we got information. So I'm going to show you what's going on. So we got events. So I'm not very comfortable with this observation, but it's, do we have a birth, a marriage, or a death? Okay, sometimes we got two of them, so it's, we might think, okay, if it's birth and death, maybe that person was born and died in the same village, right? So it's quite difficult to understand exactly what's inside, but sometimes we got all the events. Okay, so he got, well, at least one birth, maybe one or two weddings, and then one event for the death. Okay, so this is what we have for those kind of data. We got locations. Okay, so we got the name of the village. It was recoded with some official zip codes in France. Okay, and then we got latitude and longitude. I'm not going to spend a lot of time on that issue because it's complicated. Because if you think about that, we're back 200 years ago, and some parts in France of what is France now was not France. Okay, so we got some complex issues about comparing with official statistics, because actually there's not what we have nowadays. Okay, so some parts of France were not France, and we have to deal with that. Then we got information about dates. Okay, so usually it's date of birth, date of marriage, and date of death. And you can see that sometimes we got missing data. Sometimes we got stupid data, like someone died before getting born. Okay, so we have to deal with that. And then we got some ID, and the ID is related to the user and the name of the guy. And sometimes some people will appear twice because maybe some of us share a same ancestor. Okay, so if I do my tree, if someone of you within the audience makes his tree, we're going to get someone which will be in common, right? So we will both put the same guy, right? And the idea is to merge everything together and try to simplify and extract information. So for instance, for that one, we don't have the age of death. Maybe someone has the same guy in his tree and he put the information, right? So we did spend some time on that. And then we got parents. And that is good because now we have IDs, okay? So if you think in terms of networks, we got nodes and we got ages. Ages being father and mother, okay? So we got all those nodes around, and then we got, for each of them, most of the time, right? Sometimes we don't know anything about the parents, but sometimes we have information about the parents. Okay, so we've been playing with that. And if we get back to the trees, so trees are not sorted the good way to do what I was telling you about, which is starting from a village and see how it spreads, because it's based on what is called ascendant genealogy. You start from you and then you grow the tree, right? So for instance, here we got two persons, Charles and Adele, okay? And we don't know that they are brothers and sisters, right? What we got, it's two lines in the data set, but they have the same parents, right? So we're going to know that they are brothers and sisters just because they share the same parents, right? So afterwards, we're going to do the reverse. So we will start from some people and try to see the descendant. So it's looking at the data set backward. Okay? So we did spend a lot of time going through the data set, right? Because everyone was defined by the parents, but actually we wanted to look at the kids. Okay, so we did spend a lot of time on that issue. Okay, and then we got the big problem of constructing the dataset and cleaning the dataset. Because if you look at that, you got some people created by some different users, but they are the same, right? And sometimes we can extract information we got from another one to complete, right? So for this one, we don't know the time of death, but we got it from this one. Okay, so we did spend some time. So we got 6 steps to work on that. So we spend also some time on typos, because sometimes there were some typos in the names. Okay, so sometimes they add something. So sometimes it was Pierre, sometimes it was Pierre Alain, and we have to play with that and make sure that we don't merge 2 persons that are not actually the same person, right? So they have to get very close name, very close date of birth, similar parents, hopefully, and things like that. So we did spend some time on that. Okay, so we did clean the data set. Okay, so finally we ended with 2.5 million people. Okay, so it's already quite a large data set. So this is what we got. So we started with a lot of people over 4 years, and then we look at their kids. Okay, so their kids are the part on the left. Then we got their grandkids, and then we got the grandkids. Okay, so this is what we have. And so just to get back on the story of the 4th V, validity, so we wanted to check how does it compare with official data. Okay, so we don't have exhaustivity. We cannot have everyone, but it looks like in some parts we got at least 50% of the population, right? So it's quite good. In some regions we got something like 10%. Okay, so it's not exhaustive, but it looks like we got a lot of data. And sometimes it's gray because, well, officially it was not France, right? So it was not in the official statistics records, but we got that because of the website. Okay, so we did look at that. We did look at gender ratio. Maybe I will skip this part, but we got some small issues. Okay, it's not exactly the official one, but it's well documented in literature that there are usually underestimation of women in genealogical data. So we get back something which is official. So just to focus a little bit on mortality, I'm just going to show you the graph. So we got so for those of you who know demography, there are some issues on how do we define life expectancy. Okay, life expectancy is something very complex because if you want to do it properly, you have to make some projection, right? So if I want to know about my life expectancy, I'm supposed to be projecting the probability of dying next year and maybe in 20 or 40 years, right? And I don't know exactly what will happen. So we're using some prediction on life expectancy. So if you think of in terms of a Lexis diagram, we're going to work through cohorts, right? And the good thing is in the data set we have that, so we can do that. But the problem is we cannot compare with official life expectancy because usually it's not done on a cohort, it's done vertically. So we have some small issues on that. But we've been able anyway to reproduce more or less what was observed in the data. So this is the official data and the one we have. Okay, so the dotted line is the historical one. The plain line is what we have. And it looks like we're very good. So this is the survival probability, and this is the force of mortality, which is the log of the probability to die within a year. Okay, so it looks like we're very, very good. We got some small issues on young people, but if you think about that, it's normal. I mean, you will not put information about a grand ancestor who died at 15 because he will not have any kids. So usually people in genealogy do not really care about those people who do not have kids. Okay, so we got an underestimation, but it's normal. And we got a small issue here with all people, but here my concern is more about the official data because official data have been smoothed a lot. So I'm not sure about who's right, who's wrong, but it looks like in the middle we're very good. Okay, so we have something which is nice, and we have some differences. But when we look at spatial differences, actually we're very consistent with official data, right? So in this part of France, from our perspective, people die much younger, which is also what is officially said from standard historical data, right? So this is what we got, and maybe I'm going to stop here because actually I don't have enough time. Thank you very much.
Thank you very much. Unfortunately, we are running out of time, so there is no time for questions, but I'm sure that in the lunchtime you can...
Yeah, I will be around. If you got any question, just come to ask me. Thank you.
Thank you very much.